Hello students, so let's continue with constructions. So in the previous video we had learned how to construct similar triangles. So in this video let's learn how to construct tangents. So we already know that if a point is on the circle, then we can construct one tangent to it, and if a point is outside the circle, from that point we can construct two tangents to it. We have already discussed this in the circles chapter. So let's start with the first question. The first question: draw a circle of radius 6 centimeter. Okay, from a point 10 centimeter away from its center, construct pair of tangents to the circle and measure their lengths. Okay, so here once again let me, okay, the radius is 6 centimeter. So we have to construct a circle of radius 6 centimeter. Let's do that. It's very easy. So let's say we have constructed a circle of radius 6 centimeter. Let's say O is the center, and what is the radius of the circle? 6 centimeter. From a point 10 centimeter away from the center, meaning from the center, draw a line of 10 centimeter. Okay. Now it's like this point P is at what distance? 10 centimeter from the center, isn't it? So that's what we have done. From the center, you draw a line segment of length 10 centimeter and take this point as P. Now from this point, we have to construct two tangents, isn't it? We can draw two tangents from an external point. So we have to construct tangents from this point. Okay. So this is the given thing. Let's understand how to draw tangent. The first step is to draw the perpendicular bisector of this line segment. Okay, what is perpendicular bisector? It is a line which is going to divide this line segment into two equal halves. At the same time, it will be perpendicular to this line. How do we draw this? Very simple. With O as the center, that is, keep the needle of the compass here. Now take more than half of this line segment, more than half, something like this. Take more than half of this, cut an arc above and below the line. Okay, with O as a center, taking more than half of this, an arc above and below. Now don't change the measurement. With the same measurement, keep the needle of the compass at P. Now cut an arc above and below, so both will meet at some point. Let's take it as this, as let's say D and E. Okay, now join this D and E. When you join it, okay, it's gonna meet this line, isn't it? Let's take that point as M, meaning that will be the midpoint because we have drawn the perpendicular bisector, isn't it? So this half OM will be equal to MP. Okay. Now the next thing that we are going to do is take OM as the center, meaning keep the needle of the compass here and the pencil here and draw a circle. When you draw the circle, it will exactly pass through P. Okay, it will exactly pass through P. You'll get a circle something like this. Okay, now the original circle and the new circle are meeting at 2 points A and B. So join it with P. Okay, these are your two tangents. PA is one tangent and PB is another tangent. Okay, this is how we draw. Let me do it again. First we add a circle, okay, of given radius. Now from a point 10 centimeter, P is a point at 10 centimeter. We drew that. Then what is the next step? Draw the perpendicular bisector. That is, take O as a center, meaning keep the needle of the compass here. Take more than half of this. Cut an arc above and below with the same measurement. Now take P as the center, cut an arc above and below. Join these 2 points. While joining, this is going to meet the line somewhere here. So let's take it as M. The next step is take M as a center. That is, keep the needle of the compass here, the pencil here, and draw a circle. It will exactly pass through P. It will exactly pass through P. Okay. Now these two circles meet at 2 points. Take this as A, take this as B, and join it. Okay. Now what is the logic involved in this? Okay. Now if you observe this line, forget about this circle. Forget about the original circle. This was our original circle, isn't it? This was our original circle. I have erased it. Okay. Now what is the logic that we have used? See, this was the line segment from center O. P was at 10 centimeter. we divided into two equal parts so that, see, this OP is like a diameter and this OM and MP is like radius. So using OM as the radius, we draw a circle. Why did we do like this? Since if this is the diameter, the upper part becomes a semicircle and the lower part becomes a semicircle. And what is the angle in a semicircle? 90 degrees, isn't it? What is the angle in the semicircle? It is 90 degrees, isn't it? Now, if you observe, you had a circle like this, isn't it? Now, the concept here is this line is the radius and this is tangent. The angle between the radius and the tangent should be how much? 90 degree. So that is why we drew a circle with this as the diameter so that we get 90 degrees here. Okay. This is the logic that we have used. I hope you have understood how to construct a tangent from a point outside the circle. This is what we are going to follow for all the problems. Okay. If a point is on the circle, then how are we going to draw this? Let's understand this by another question. That is the fourth question. The remaining questions you can do it on your own. And if they, in the exam, if they ask you to verify the length of the tangent, see, you can measure it using the scale. But if they ask you to verify the length, then it will be equal to, the length of the tangent is L square. L is equal to square root of D square minus R square. How did we get it? See, this is a right angle triangle. If I take this distance to be D and this L as the length of the tangent, this is the radius. Using Pythagoras theorem, we get this. Okay. This is the formula that we are going to use to verify, where D is the distance between the center and the point, R is the radius of the circle, L is the length of the tangent. Okay. For the next questions also, you can do it in a similar way. Okay. So let's get into the fourth question. The fourth question, draw a pair of tangents. This question is very, very important compared to all other questions. Draw a pair of tangents to a circle of radius 5 centimeter, which are inclined to each other at an angle of 60 degree. Okay. So we have to draw a circle of radius 5 centimeter and we have to draw two tangents to that circle in such a way that the angle between the tangents is 60 degrees. Okay. Now let's draw a circle of radius 5 centimeter. Okay. This is a circle of radius 5 centimeter. Now for this circle, we have to draw two tangents. Okay. And if you extend the two tangents in such a way that they meet, the angle between the two tangents should be 60 degrees. Now remember, let's say this is the figure that we need. From a point, we are drawing two tangents. Let's say we have got something like this. The angle here should be 60 degrees. Now let me join this point of contact with the center, this point of contact with the center. Remember, the angle formed at the center by joining the point of contacts, this angle and this angle are supplementary. So if you want to have 60 degree here, what is the angle that you should have here? 120 degree. So automatically, if you construct 120 degree here, then the angle between the tangents will become 60 degree because the angles are supplementary to each other. Supplementary in the sense, if you add, you will get 180. So if you want 60 degree here, construct 120 degree here. Okay. That is the logic. If you want 50 degrees here, construct 130 degrees here. It's like that. Okay. So let's take a circle of radius 5 centimeter. Now here we have to construct 120 degrees. How do you construct? First, let's join this. Let's take this point as P. With O as the center, draw a semicircle. With O as the center, draw semicircle. Now from this point, don't change the measurement. This point, from this point, cut an arc. That will be 60. Again, from this point, cut an arc 120 degrees. I hope you guys know how to construct 120. So join this point and this, extend it. So this will be Q. Okay. So we have constructed 120 degrees at the center of the circle. Now, at the end points, we'll draw tangents. Okay. These are point of contacts. We have to draw tangents. Okay. How do you draw tangent? Very simple. This is radii. And the tangent that you wish to draw should be perpendicular to this, isn't it? That is the angle between the radii and the tangent is 90 degrees. So simply construct 90 degrees here. How do you construct? With P as the center, semicircle. then from here 60, then from here 120, then you will bisect it, you will get 90, isn't it? So this will be the angle extended. Now this is the tangent. Why? Because the angle is 90 degree and this is radius. The same thing here. Semicircle 60, 120 and bisected you get 90. Extended. Both will meet at a point, isn't it? Both will meet at a point. Let me erase this. Constructions topic. Both will meet at a point. That point, let's take it as T. Definitely here the angle will be 60 degrees. Okay. This is the logic that we are going to use. So at the center, if you want 60 degrees here, construct 120 degrees here. At the end points, draw 90 degrees. You guys know how to draw 90 degrees, isn't it? So draw 90 degrees at P, 90 degrees at Q, extend them. They'll meet somewhere. That point, you take it as some alphabet, T, X, whatever. Then the angle will be 60 degrees definitely. Okay, so TQ and TP are the two tangents. This question is very, very important for the examination. Okay, if suppose here the angle has to be 70 degrees, then here you have to construct 110. Okay, using the protractor. Suppose if you want here 80 degrees here you should have 100 degrees. Construct 100 degrees. At the end points, draw 90 degrees. Extend them, they'll meet somewhere here. Definitely you will have 80 degrees here. Okay. See the other questions you can try it on your own, which are less important from the examination point of view. But these are the important questions that are going to appear in the examination. So I have explained it. Okay. Thank you, students.